Okay, let's get started. Thanks for joining us today. My name is Brett Arnott. I'm a Senior Systems Engineer at Primary Data. We're excited to welcome everyone to this webinar. This is the first in a three-part series talking about the benefits of primary data in terms of the business problems we can solve around data mobility and around the movement of data. We have a great agenda today where we'll explore the problems associated with moving data and how primary data can help solve those problems. So as I mentioned, today we're talking about data lifecycle management, or in other words, what storage should my data be on now and why is it so hard to move it there? But before we get started, I want to talk about our founding team at Primary Data. Primary Data was founded by David Flynn and Rick White, the two gentlemen in the middle who also co-founded another company called Fusion.io that pioneered the use of Flash in the data center. After Fusion.io, Rick and David decided to start a new venture, which is Primary Data. And the problem they wanted to solve was not only for performance, but to really help their customers manage data better by giving organizations a lot more visibility into where the data is located, how the data is being utilized, and what resources are being consumed to manage the data, and how to place in controls to help orchestrate the movement and management of data throughout its life cycle. Our CEO, Lance Smith, also came from Fusion.io, where he was the former president and COO. And our Senior Vice President of Sales and Products, Casey Lai, came from a number of companies such as EMC and VMware, as well as startups such as Avamar, Delphix, and Versto. As for myself, I came from VMware and EDS and then Hewlett-Packard before joining Primary Data. So thanks again for joining. Let's get started. Our agenda is, as I said, is packed. So today we're going to first look at why is data lifecycle management so hard, then what's the solution for solving the problems, and that will include a demo. Then we'll look at how the solution works, and again another demo. Awesome, two demos in one webinar. Then we'll look at what else the solution can do, how specific industries can benefit from the solution. And finally, before we wrap up, we'll look at where the ROI of data lifecycle management is. Then wrap up and we'll take some questions. So why is managing the lifecycle of data so hard? Before we answer that question, let's quickly review the fundamental concepts of data lifecycle management. Data lifecycle management, as the name suggests, is about managing data over its lifetime. At each stage of the data's life, and those stages may differ by organization and industry, which storage should the data be on? When the data is active and important, for example, and important to the business, it may need to be on the highest tier of storage. That may be tier 1, so it gets the highest performance, highest protection, but it also may come with the highest price or cost. As the data ages and becomes less active and less important, the data may no longer benefit from being on the highest tier of storage and can be moved to a lower tier. And finally, again, as the data ages and becomes inactive, it can be moved to a lower tier of storage to reduce the cost or the price of storing that data. Throughout the life cycle, data may move up and down between those tiers as the activity and importance changes. So data lifecycle management is really about ensuring your data is in the right place at the right time. So why is data lifecycle management so hard? Well, first, because moving data is so hard. And it's hard for three reasons. And in order to understand those reasons, it really is about answering three questions. One, where is my data now? Two, how much is it costing me to store my data? And that's not just cost in terms of dollars, but it could also be performance as well. Is my data sitting on storage that's not delivering the performance that it needs, and therefore I'm getting a performance cost? Or is my data sitting on storage, high performance storage, when it doesn't need to be there? And it could be taking up resources that other data or other applications could be using. And then finally, the third question, where should my data be? And once you can answer those questions, you can then move data. Now, the problem with moving data is it's difficult, it's time consuming, and it takes a lot of people to do. And also takes a lot of time to analyze the information you have out there to answer these three questions. And no one really has an army of free resources sitting around to answer those questions and move data. Now, studies have shown that it is common for up to 80% of data on storage to be inactive. So if we quantify the cost of that problem, you'll see there's a significant cost associated with storing inactive data on high cost or even medium cost storage. So you have an all-flash array for one of the big names in storage, and all-flash arrays are expensive, so let's assume that the fully loaded cost per gigabyte is $15. Say you have 30 terabytes of data on the array, and of that 30 terabytes, 80% of it, or 24 terabytes, is inactive and doesn't actually need to be there. So the cost of storing that inactive data is $360,000. Now let's compare that to the cost of storing the same data on a cheaper storage solution, whether that be a software-defined NAS or object, cloud, whatever it may be. And for the purpose of this demonstration, we'll assume that the cost per terabyte for the cheaper storage is $2. And as we've seen out there, cloud and other cheaper object and even on-premise scale-out NAS solutions can even reduce the cost lower, even down to half a dollar, so 50 cents or less. So let's assume that the cost of storing that data at $2 per gigabyte is $48,000. So really, by moving the data to the lower cost storage, the cost of storing that data will save you $312,000. So the cost of storing the data, in other words, right now on the higher cost storage is costing you $312,000 more than it should. So the second reason that moving data is hard is because you need downtime. And let's face it, who can really afford downtime in their applications to move data around? Too often the business impact is the justification for not doing anything, i.e. not moving data, and that's why data ends up staying where it is. And finally, the third reason that data is difficult to move is because it's trapped in each array, creating storage silos. It's extremely difficult to move data between the different storage devices, whether it be because of their different vendors, different protocols, whatever the reason may be. There are storage silos and it is difficult to move data between them. Let's face it, they're called storage silos for a reason. So what's the solution? Some vendors have attempted to solve the problem by building storage arrays that have multiple tiers of disks and automated storage tiering software that moves data from the top tier of disks to the lower tier within that array. The data never leaves the array, so that another storage silo has effectively been created. So we don't see that as the solution. We think the solution is something far better. By taking the storage that you already have and unlocking the data from the array, the data is free to move across the storage devices, types, and vendors. And then by adding client-side statistics to truly understand whether the data is getting the performance it needs, and the concept of objectives to match the needs of the data to the storage that can deliver it, you'll have unparalleled visibility into where the data needs to be throughout its life cycle. And finally, automated data movement so that your data is automatically and without downtime moved to the right storage. So let's take a look at data lifecycle management in action with a demo. Now in this demonstration, we'll show you how the solution can identify how the solution can move data non-disruptively. And in this demonstration, I'm going to move data from EMC Isilon to NetApp 7 mode. Now, even though in the diagram here I say that Isilon is slower and NetApp is faster, I'm not trying to insult anyone's personal preference or anyone's belief in different storage systems. It's just for the example purposes. What I'm going to simulate is that data can be moved non-disruptively, and I'm going to manually trigger the move of data from, say, a lower tier to a faster tier of storage to show how data can be moved around. In this example, I'm going to start a movie. We're going to watch a movie file, and then I'm going to change the objective to make that file move. And we'll continue to watch the movie file, and you'll see there's no disruption to the movie before, during, and after the move. The move happens automatically once I trigger it, and you'll see that we go through a process of checking compliance on the file. So at the end of this demonstration, you will see that a movie file was moved from Isilon to NetApp. It was done without disruption, and it was done automatically. So let's go take a look. Let's take a quick look at the environment first. So here's the file that the movie file we're going to watch. As you can see right now, it's sitting on, the current storage volume is EMC Isilon right here. And the current objective that I have is for EMC. I'm going to change, after starting the movie file, I'm going to change this objective to NetApp, and we'll watch the movie file change locations. Now, here's the movie file. I have just mounted the volume onto my computer, and we can see the movie file here. So let me start that, and we'll make it turn off the sound so we don't have to listen to the sound, and we will make it a bit smaller so we can actually see it on the screen here. So let's start playing the movie. Now, I apologize for those watching this remotely over WebEx. I'm not sure how well the quality of the movie will come across in the WebEx. So we're playing the movie. Now I'm going to go and change the objective to NetApp C mode. What I want you to do is continue to watch. Oh, it's already gone out of compliance. We can see that the file is no longer in compliance with its objective. So the next things that we would expect is that this file will start moving. Now the file may move very quickly, so just watch the storage volume here because that's what we want to see change. When the screen refreshes again, the file may have already moved. It shouldn't take too long. What I'm going to do once the file moves is we'll pause the video and we will play it again, and we'll show you that it can pick up from the same position. There we go, it's moved. So let me pause that. You can see the file has moved to NetApp storage and is now in compliance. I pause the video, let me play it again, picks up exactly where it was before. So we were able to watch the video all the way through. I'm going to go back to this share, and you can see I didn't remount it or anything. I just wanted to go back in and show you that the file is still there. I will start it again, and you'll see that there's absolutely no disruption to the file, and I can still play it. So even though it's moved, the file is still accessible, and there's no downtime. So in terms of your applications, if data is moved, your applications will always know where that data is, and there would be no disruption when the data is moved. So let's go and take a look at how this works. So how does this solution work? First, we saw the reasons why data lifecycle management is difficult, and we saw a demonstration of the solution of the problem. We also talked about the solution for the problem as well. Let's dig a little bit deeper into how it works. First, we share the solution. First, we will share how the solution unlocks the data from the underlying storage. Then we'll share how storage capability and client-side statistics are used to determine where the data should be. And finally, we will talk about the matchmaker that matches the data to the right storage, i.e. the objectives. So typically in traditional storage, each storage array has its own control and management functions. And this is really the reason why it is difficult to move data between arrays and vendors. To solve the problem, the control and management functions are separated from the storage. This means that the storage array only needs to handle the storage operations, like read and write. The layout and metadata operations are offloaded, which can improve the overall performance of storage. Now that there is common control and management across all storage, data can freely move between storage devices without the usual constraints of vendor or storage type, or without the usual constraints of manual effort as well, or downtime. This means you move away from managing multiple physical storage arrays to managing one logical storage resource. And now that the control path is separated from the data path, The layout and metadata operations are taken care of by a dedicated, highly available, and high-performing controller. And the application servers continue to read and write directly to the storage where the data is located. So they still have a direct data path to the storage. If the data moves between storage, say from SAN to NAS, the application servers get the location of the data from the controller and then read and write directly to the NAS to the storage. The solution will handle protocol translation between block, file, and object, and there's no need to shut down the application and remount storage. The solution is storage agnostic. As you can see here, we've got some examples at the bottom of different storage types, but this can also represent different storage vendors. And will even allow you to adopt new technologies like object or cloud and direct attached storage without any changes to the application and without application downtime. Now, in order to decide where the right place for the data is at this point in time, the solution needs to understand the capability of the storage and what storage storage performance the client needs, what it is actually getting now, and then have some way of matching the two together. So in this case here, we have a database that says I need 20,000 IOPS and 1 millisecond of latency, but I'm not getting it. There then is a storage match. They can say, well, I can actually deliver 30,000 read IOPS and I can deliver less than 1 millisecond of latency. When that match is made, then the data can be moved to the storage device that can deliver the requirements that the application needs. The application has no idea that it's moved and will just start getting the performance that it needs. Now, by owning the control and management functions of the storage, the solution knows what each storage array is capable of. Here's an example to show that the solution knows the read-write performance in terms of IOPS, latency, and bandwidth of the underlying storage. And we know that for all storage devices. Next, because the solution has access to client-side statistics, it can understand the current actual storage performance the client is getting. If the current performance does not match what is needed, then action can be taken to move data to storage that can meet data's needs. The indicator of whether or not the data is getting what it needs from a storage is compliance. Non-compliance means the data is not getting the performance that it needs. Once data is out of compliance, the solution will find a better storage match and move the data. So that's the awareness piece. If the data is out of compliance, then we'll take action to find somewhere to move the better place to move the data to and move the data. And finally, the impact. So we've got the awareness, the action, and the impact of the outcome. Once we're back in compliance, the impact is that data will get or the business even will get what it needs from storage, and it'll do it without downtime and without the additional costs of manual effort. So how do we know what performance the data actually needs? It's the objectives. The objectives matches what the data needs to whether or not it's getting it, and can match that to the storage that will deliver it. Now, this whole process that we talk about here is automated, and it can be done at a much faster rate than humans can do it, and a much bigger scale as well. So let's look a little bit more at the objectives. Objectives define the data's requirements for storage in terms of performance, which we discussed, protection, and cost. Objectives are applied to data and can be applied to a whole share, a specific folder, or individual files. The objectives are the matchmaker between what the data needs and what the storage can deliver. Let's say, for example, you have 50 terabytes of data that needs 100,000 IOPS, and you only have 40 terabytes of data in your storage that can deliver 100,000 IOPS. How would you decide which gets the faster performance? The cost objective you see down here can be that decider. It can be, and this can be done in two ways. The simple way is to set a priority on the data. The higher the priority data gets, the faster performing storage. The second way is to set a price. As the demand for faster storage goes up, so does the price of the storage. The objective sets the price that the business is willing to pay for the storage, And if the price of the storage exceeds the price they're willing to pay, then they don't get faster storage. Smart decision making is in an extremely agile manner. Now let's take another look at data lifecycle management in action. In this demonstration, we'll use the same storage, but this time I'll create and write a file to generate IOPS and automatically trigger file movement. So that we can get a better understanding of how the solution works, we will walk through the process in more detail, and we'll look at how data is selected and where to move it to. It all actually works. And at the end of this demonstration, you'll see that the data is moved from Isilon to NetApp and back again, and we'll understand why it moved. So we'll go back to here. What I'm going to do this time is I'm actually going to generate a file. So let's go and generate that file now. Okay. We've generated a file. Let's go and refresh the screen here. And I call this file new file. There it is there. There's our new file. And you can see it was created here as well. So a very simple example of creating the file. And it was created on the EMC Isilon. What I'm going to do is something a little bit different this time. We're going to look at the statistics of this file. We can see what the current objective is. We can see what the performance requirements are for this file. But I'm going to watch the chart down here that's going to pop up. Now I'm going to start writing to this file. I want to generate some write IOPS so that we can trigger some activity on this file. The objective that I currently have, the objective that I currently have set here is what we call a smart objective that will change based on the requirements of the data. And so as the IOPS increase, the smart objective will change so that the file will move from EMC to NetApp. We're saying here that NetApp is going to better meet the performance requirements of this data, and so therefore we want our system to determine when those requirements aren't being met by Isilon and make the move. Now I want you to watch a number of things. This chart will start going up as the IOPS activity increases, and you'll also notice over here this will eventually turn red when the file goes out of compliance, i.e. when it's not getting the performance that it needs. This will take 30 seconds or so to trigger, and then we will watch the file move. As you can see there, we've been tracking the activity. There hasn't been any activity, a high level of activity on this file yet. That will change shortly as we write to that file. Now, what you can expect to see is exactly this. First, we changed the objective to NetApp C mode because the file was not in compliance, and we need to change the objective so it will move to NetApp C mode. We're not in compliance here, and we can see we're severely out of compliance right now. If we go up here, we can actually see that the file is moving. And we will wait for that file to finish moving, and we'll see that on this chart as well. And once it's moved, I'll stop the writes to the file, and we will take a look at what happened. Now, once I stop the writes to the file as well, we've set an objective. It looks like it's moved, so this will update in a moment. We will set an objective on the file. We've set the smart objective on the file to move this automatically back to Isilon when it's no longer active, and that should take about a minute or so. But before we do that, let's follow along this chart. First, because the file was out of compliance, the objective changed, and so we could move this to NetApp C mode. Once the file had moved, you can see here it moved from Isilon to NetApp. It then went back into compliance, and we can see that also here on the table. Our target here said that if IOPS were greater than 1, we need to change it to NetApp C mode, which is what happened, which means we went out of compliance from where the data is currently. We then moved the file from Isilon to NetApp, and we're back in compliance again. Now what will eventually happen is this file will go out of compliance again because we have set another smart objective to say if it's been inactive for a period of time, let's move it back. And that should take a minute or so for that to happen. You see we got up to 23 IOPS of activity there during this process as well. Now while we're waiting for that to move, let's go and take a look behind the scenes of the fundamental pieces that made this all work. You can see here I have an objective called promote on increased IOPS. Let's go and take a look at that objective and see what that looks like. What I have here is in the SMART objective, we have the concept of a pattern, so you can select certain files or certain objects that you want to be included in this SMART objective. And a SMART objective takes has two attributes. It's a level of inactivity or activity that you can set for the data. In this case, I set a very, very low read-write IOPS activity level so that we could trigger the move of the file very, very quickly. And if we had more than 0.001 thousand read-write IOPS, the objective would be changed to NetApp C mode. We're saying here that if it needs more than that much, or if the data is requesting more than 0.001 thousand IOPS, then we want to be able to move this data to NetApp because we think it is going to get better, get the performance it needs there. We then said, okay, we want to make sure the data is only on the highest tier of storage for as long as it needs to be there. So if the file is inactive for 2 minutes, let's move it back to EMC Isilon, and the default is always going to be EMC Isilon. That's what this last one here is. So the last 7-year activity here is basically saying the default location for this file is going to be EMC Isilon. So we hit our threshold for IOPS. We moved it to NetApp C mode. We'll hit our inactivity threshold for the data, which will move it back to EMC Isilon. So it's 2 minutes we have set here, and we can go and check that and see if we've hit that 2 minutes yet. Let's go and have a look at our data, and we'll see where it's currently sitting. Still in the NetApp, it hasn't moved yet, so it should be moving shortly. Now let's go and have a look at the two objectives that we have here. We have a NetApp C mode objective, and for the purpose of this demonstration, we use a simple process of saying this objective will confine the data to NetApp C mode storage. But you can see down here the protection and the performance capability that I talked about before in the presentation. These are attributes that you can set to determine to determine what the data needs in terms of protection. So how much durability, how much availability, what the priority of the data is that I mentioned before as well. And then the performance requirements in terms of read and write bandwidth, read and write IOPS, and read and write latency. And this allows you to easily match the capability of the storage to what the data needs. And this is very similar to the way that we set up the Isilon objective as well. Let's go and take another look at our guy here and see if he's moved yet. Okay, so if you can see down here, it's actually moved back to Isilon as we instructed it to through our SMART objective. We can see here our latest activity was it moved from NetApp C mode to Isilon based on the fact that we had a SMART objective that said when the data is inactive, move it. So if you think about everything that I just ran through for your organization, we ensured that the performance requirements of the business were being met by automatically and non-disruptively moving data to a higher performing storage. And I was writing to that data the whole time it was being moved. You saw that I didn't stop the writes until after the data had been moved. And then when the data became inactive, and that you can set that inactive threshold to a time period that suits you and your business, 1 year, 2 years, a few months, whatever you need it to be. But in our case, when the data was inactive for 2 minutes, it moved it back to the lower cost storage. This enables you to balance the mix of high cost and low cost storage in your environment to make sure that you're spending optimally on your storage at all times. So let's take a look at what else the solution can do. Now that you've seen what the problems are that we can help solve, how we solve them, and you saw two demonstrations of how the solution works, let's talk about what else the solution can do. As you saw, the solution moves data non-disruptively. That means that you can use a solution for data migration, non-disruptive data migration. So, and you may use data migration to upgrade storage, to do storage refreshes, to adopt new technology, to help with mergers and acquisitions, as an example. You can also use the solution for scale out, whether that's scale out NAS as an example, so that you could automatically load, capacity load balance across a scale out NAS solution. You can use scale out to reduce costs, so you can scale out to other solutions as well. You can use scale out for performance. You may want to be able to add low cost, high performance direct attached storage with SSD or NVMe for a low cost scale out NAS solution. We talked about data lifecycle management to increase performance and reduce cost, but then there's also the capability for data protection to improve backup and DL processes and to improve recovery as well. Now, at the fundamental core of all of these, of everything that we can help with in terms of other things this solution can do, the fundamental core is data movement and non-disruptive data movement, and non-disruptive data movement efficiently without the usual burdens of downtime and manual effort. So who can benefit from this? Everyone can benefit. Anyone that has storage and have a trouble managing storage and the cost of storage and the putting the data in the right place at the right time can benefit from our solution. But for specific industries, there are benefits. So for media and entertainment companies that are producing content, they can benefit from being able to archive to low-cost storage like object or cloud without losing access to the data. They can also have fast, cost-effective scale-out storage solutions, as an example for a scratch space for LE content development. And non-disruptive data migration without manual effort to move completed TV shows and movies off Tier 1 storage, and the ability to choose any storage type or vendor at any time without disruption. Life sciences, in most cases, are managing content as well. They're managing images from microscopes. And that data ages over time, but they may have a requirement to maintain that data for 7 or more years, and is better and more cost effective for them. I will help them keep their costs down if they can automatically and non-disruptively move that old data to cheaper storage, whether it's in the cloud or whether it's on premise. For travel and IT services with complex and large environments where they store a lot of data, being able to get a view of all of the storage in the environment, understand where the data is at all times, and ensure the data is sitting on the right storage at the right time will ensure they're delivering cost-effective services to help with profits and help improve customer success for IT services, as an example. And for travel and retail as well, the solution helps with seasonal workloads where there's peaks that normally take 6 months or 12 months in advance planning to get prepared for. Our solution can reduce that lead time and also reduce the cost and manual effort required with meeting those peak season demands. So where is the ROI in all of this? And what we have here is a real-world example of comparing the total cost of storage without primary data and with primary data. And this comes from a large organization with many different types of storage. And this is not uncommon across the industry. So the cost of storing data on Tier 1 without primary data for this company was $6.3 million, and that was the cost of all of their Tier 1 storage that they had. Working with us, we could help them reduce the amount of inactive data on Tier 1 storage, so that reduces the cost of storing data there significantly. And then we can help them replace their expensive tier 1 storage with a fast scale out NAS with either SSD or NVMe drives to really give that high performance but low cost tier 1 performance. And then the cost of storing data on their tier 2 was $4 million. And again, by helping them automatically reduce the amount of inactive data on the tier 1 storage, we could help them reduce that cost of storing data down to $1.5 million. So a significant decrease in the cost of storing data. They didn't have an archiving strategy, and so therefore they didn't have a way of really archiving their data and moving inactive data to a really low cost solution. So with Primary Data, we were able to help them introduce and adopt a low-cost object storage solution that they could move the inactive data to and reduce the total cost for storing that data. They were also paying for a vendor-specific solution for doing automated storage tiering within a single array. So one of their tier 1 arrays had multiple tiers of disk in it, and they were paying for the software in order to move data up and down within that array. With our solution, they could stop paying for that automated storage tiering within that array for that software, and we could save them $1.1 million on that single array solution only by replacing it with our solution that could move their data across all of the storage that they had, not just up and down in one array. So the total difference between the cost of storing data without us and with us was $9.5 million for this customer. That is a significant reduction in the cost of storing data, and definitely a compelling return on investment for this organization or any organization. So at Primary Data, we're very proud of our solution, and there are two core components of our solution. They are the DataSphere and the DSX. The DataSphere is the universal control plane that manages the layout and the metadata and decides where to move data to. It also has the data analytics, i.e. the client-side statistics, to understand what performance the data is actually getting now and what it needs so that we can match, using objectives, the data's requirements to the storage that can deliver it. The DSX, or the DataSphere Extended Services, has three roles. The first role is the data portal. The data portal makes it possible to move data across file, block, and object because it takes care of the protocol translation. The second role is the data mover. As it sounds, the data mover actually moves the data and is the reason why data can still be accessed while it's moving. And finally, the last role is a software-defined storage using commodity x86 hardware. In other words, software-defined storage. So we have a complete solution for effective data lifecycle management in an automated and efficient way. Appreciate everyone for joining. Let's go over a quick wrap up, and then we'll head over to Q&A. We'll answer some of the questions that have come in on the chat while we've been going through the presentation. I've seen some questions pop up, and we'll also take questions from the phone as well. So please attend our next webinar on data migration without downtime. Now, the date is subject to change. It is tentatively scheduled for the 19th of July, but that may move to the following week, perhaps the 26th. We will let you know what the date for that is, but please do attend the next webinar. Meet with us to discuss your situation, or at least get a deeper dive demonstration so you can see more of what we showed you here today and understand how it could work in your particular situation. Simple, email us at deepdive@primarydata.com and we'll get back to you. And in the meantime, view and download some great resources from our website at www.primarydata.com. Oh, one more thing I failed to mention, and we didn't include this in our slides up front, but I wanted to leave this as a surprise at the end. Steve Wozniak, yes, Steve Wozniak of Apple fame, is our chief scientist. It's a great, it's great to be able to work with such someone so well renowned in the industry, and someone has shaped the personal computing the way that he did. So we're very lucky here to be able to work with Steve. So let's get into Q&A. We'll start with answering some questions.